Hi, do you hear me?
Yes, I do.
Great. Do you know, will anybody join us today?
I'm not sure. I know that someone is having a mathematical practicum on this time, and someone has a lecture in mathematics and reinforcement learning. So maybe it's a reason why no one is attending.
Okay, all right. So let's wait for around 5 minutes.
Yes, I think we can expect some people.
Excuse me, can you repeat?
I think we can expect someone, at least.
Okay. I think we will maybe we will try to wait for 3 minutes or a little bit more.
Yeah,
But
it's okay.
yeah, if nobody will join, we will start a seminar today, and I think today it would be shorter because we will not have test today, and maybe we will finish earlier.
Okay, that's okay. If we have a minute,
Yeah,
it
of
seems.
course,
May I ask a question?
of course.
I went through the curriculum on GitHub, and I didn't see anything related to name entities recognition in this course plan. Is it really so? Will we discuss this problem?
Okay, so we will discuss BERT architecture in a few lessons. Um, all the time, name entity recognition connect with encoder-only architectures. Maybe we will not have this topic this year. But it's just fine-tune task for encoder-only architecture, and I can just send you, if you will not have this, I can send you a notebook for fine-tuning for this task, and it will be a short code, and if you will look through this material, I think you will not have problem to fine-tune it. But right now, I think everybody use name entity recognition task with large language models, and we will have large language models topics for 2 seminars in the end of the course. So it would be connected with this topic, and I think you will not have problems at the end of the semester.
Okay, thank you.
Why are you interested in this task?
Well, just in case, I'm interested in any typical NLP tasks. Just used to see this kind of problem among the typical problems dealt with any course. That's why I asked.
Okay, I can send you a link to the materials.
Yes, in fact, any additional materials would be great.
Yeah, okay. It's a Hugging Face course, and there was some information about this. But several years, I think we use a lot of tasks which was connected with different architectures. I think this year and maybe last year, it almost connect with large language models. So I think right now one architecture can solve a lot of tasks like simultaneously.
Okay, thank you.
So, okay, I think we can start. I will share the screen. Okay, do you see my screen?
Yes, I do.
Okay, super. So today we are going to build a neural machine translation model using PyTorch. The focus is on understanding the sequence-to-sequence architecture. Sometimes it's sometimes people write it like sec-to-sec. It's architecture for translating sentences, and we will solve this task. We will translate from German to English on this lesson. So in the introduction, it's overview of sec-to-sec model. This model consists of two main components. It's encoder and decoder. You can see it on the screen right now. The encoder reads the input sequence and converts it into a fixed size context vector. This context vector is compressed representation for the entire input sequence, and the decoder then takes this vector and generates the output sequence one word at a time. So we can see a visualization of this process. Maybe it looks like autoencoder in computer vision. I think we can consist it. Okay, do you have questions on this stage? If not, oh, I have some mistakes. Okay, we will install Torch text. But some mistakes here. Something weird. I will try to solve this task. Okay, strange. I will open collab right now. Maybe it would work in the collab. Okay, I will stop screen sharing for a while, and I will open Google Colab, and then I will continue.
Okay.
Okay, there are two options to write code today and solve all the tasks which are in seminar, or work with solved code. What do you want?
I do not object to working with solved code, solved notebook. For me, it's okay.
Okay, okay. Let's try to do it. Also, you'll have second homework, which consists from this topic. And so you will have time to practice it for your own. Okay, I think right now it should work. It looks like okay in configuration. Okay, I will start explaining while it's working. We will begin with important libraries that we will help us build and train our model. You know all the libraries which we uploaded, but maybe I will repeat some information. You know, PyTorch libraries. What's wrong here? I can't understand. Okay, it's the error is in this line, Torch Legacy dataset multi. Maybe it's old notebook and because of this we can't okay, let's install this version, maybe it would work. Try to install 14th version. Okay, while it's installing, so we will use Optim library to it will provide optimization algorithm for us. Also, we will use Spacey, I don't know, library for advanced natural language processing. And this dataset we will use to contain in parallel German English sentences. So I hope it would install right now, and we would be able to continue solve all the tasks. Okay, so we have put here, and I will explain what we are doing here. We need to create seed value. Do you know why do we need seed value? Actually, we needed to ensure that our results are reproducible. We need to set a fixed seed for random number generation. This makes the training process deterministic. Because of this, we need seed in all the libraries, like in what's wrong? Okay, let's try. Okay, I'll try to do some solve tasks. In my notebooks. Please wait for a while. Okay, so okay, I hope it will install right now. If not, we'll just go through code and then I think I will find issue of this code and I will write it in the chat how to solve all of this stuff. I have no idea right now why all the environments are working not in the right way. So, okay, let's try to solve it for last time, but I will continue now explaining of all the code, what we have in this notebook. Also, here we download Spacie libraries. We know that it's library that helps with natural language processing task such as tokenization, and we need to download its German and English language models. In this step, we download all the models, and then we can load them. We can load these models and for our usage. Here we can define in tokenizers. We use tokenizers to break down sentences into individual words or tokens. We reverse the German tokenization because it often helps to improve pronunciation accuracy. So here you can see output of the tokenization, and you saw it on previous lessons too. Here we have code fragment that will use our tokenizations for German and for English language. Also here we define fields with torch text, which we can't download. Okay, it's running. So torch text. Fields in torch text specify how the data should be processed. We use them to define how we want to tokenize the source German and target its English sentences, and whether to convert them to lowercase. Here we convert to lowercase with this value, and we use init token and EOS token like EOS. We had this on previous lesson, I think, explanation why we use it. So okay, it's going. In this type, in this part, we just import torch text. Then we we loaded dataset using torch text, and now we can split the data into training, validation, and test sets. Do you know why do we need 3 splits for dataset? You can answer, but if not, I will answer on my question.
I do not know, in fact, why do we need the validation set?
Okay, should I explain, right? Okay, we need a training dataset to train the model. We need a validation and test split to test our model. Why do we split it into 2 datasets? When we train our model, we can have a lot of epochs, and usually we monitor how our pipeline is going on. We see loss value. We measure metrics, target metrics, which we need to identify if task is going well or not. And in this process, we in the end of the training process, we can see all of our metrics or loss values, and usually we identify do we have overfitting task, overfitting process here or underfitting. If we will have good metrics on the training split and not good metrics on the validation split, it's signal us that we have overfitting process right now. So we should use checkpoint with good metrics on training split and validation in the same time. And so while we optimize our hyperparameters, we can observe only on validation split. And in the end, we should ensure that we didn't do something strange or maybe something wrong. And because of this, we need a second split test data. To be sure that we are right right now. And also we need statistical parameters and write statistical parameters in the same way. So because of this, we need 3 splits. Is it clear right now, or do I need to explain something in another way, maybe?
Can you tell us more about what exactly we are doing with the validation data?
Yeah, of course. You will have on our lessons, usually you can observe that we have evaluation pipeline in the end and training pipeline. And on evaluation pipeline, usually we can measure our metrics. If it is classification task, we will measure maybe accuracy, recall, precision, or similar metrics. If it is through linear regression task, we will measure MSE metric, MOE, and others. But it's not important in this moment what metric we will measure, but we can see values of our metrics. And while we train our model on each epoch, we can see our metrics on a validation set and on train set too. So usually we have line graphs or maybe another graphs on which we use and on which we can look all the time. But at the end, we need to ensure that we are right and we didn't have overfitting or underfitting, and we need to measure our metrics on test data too.
Okay, thank you.
Okay. I hope it was clear. I have no idea why it didn't work today. I will just explain you all the code that we have in the notebook, and I think tomorrow or maybe on Thursday, I will try to solve all of the issues that we have. And when I will solve it, I will write you in the chat how I did it. I think it's something wrong with my environment right now. Maybe it's not a right version of CUDA. Okay, I have I have 12 CUDA, but it tried to install this 11th version, and I don't understand what's going on here. Maybe I will try. Maybe I try 18th version and it would install me this 12 CUDA. Okay, let's continue right now. We will monitor what's going on in that cell. Yeah, so we stopped on train data, valid data, and okay, we split it all of our data into 3 data sets. And now we can see that it was 29,000 of training samples and about 1,000 on validation set and test set. So we can now build vocabularies here. From the training data, we will only include words that appear at least twice. We can see that we used this parameter here. And now we use bucket iterator here to create iterators that handle batching and waiting efficiently. So we can see that we provided batch size. Our batch size would be 128. Also, we provided all of our test splits. I mean, train split, validation split, and test. And also we provided device. And okay, I think if you will use Collab, you will have CUDA device, and it will be faster. And now we can start to discuss sec-to-sec model. I told you overview of this architecture. Let's dive into details. So in the first stage, we need to explain encoder. The encoder processes the input sequences and produces a context vector representing the entire sentence. It consists of embedding layer to convert words into dense vectors and an LSTM to capture the sequence's temporal dependencies. You can see consistent of encoder here. We provided in the visualization how it looks like. Also, we provided layers that will be in the encoder. And if it's clear, we can start create our own class for encoder. So we can see our embedding layer. For dense vectors, we can see our RNN layer, I mean, with LSTM. We studied about this on previous seminar. And also we will have dropout here. Do you remember what is dropout?
Well, it's a regularization approach technique, preventing
Yeah, we can say
overfitting of the model.
Do you remember how does it works?
Well, mainly yes, but I wouldn't like to retrieve this in my own words.
Okay. So yeah, we can on the training process we can
No, we just drop out some neurons from the general network during the training stage.
yeah, actually it's work like this. So it's looks like pruning when we using not all the neurons on the training stage. We can set frequency with which will drop some neurons, and usually it's work like regularization. It's just for refresh your knowledges. Okay, so yeah, we can see how our encoder class looks like, and we can see our forward method. So we identified embedding lawyer. We need pass into embedder lawyer all our tokenized text. Also, we will provide dropout to embedded lawyer, and yeah, and here we will use self RNN, which we initialized with LSTM. Do you have questions about this fragment? Okay, if no, let's move to decoder class. So decoder generates the target sequence from the context vector. It's similar to the encoder, but includes a linear layer to convert LSTM outputs into vocabulary-sized predictions. Let's deep into details. So now we can see that we initialize embedding layer 2, we initialize LSTM, we initialize linear layer, and we have dropout here. So what's going on forward? We unsqueeze our input because in the bottleneck we have vector. Then we provide to embedding layer, and in the end we also have LSTM. Then we need to pass it to linear layer. Because to convert outputs into vocabulary-sized predictions. Also, we need to check our dimensions that we provide to each layer. Here we will have. Okay, do you understand how many out vector features would be? It would. I just said it, but I need to check. Are you understand what is going on? Okay, it would be vocabulary sized because LSTM outputs into vocabulary size prediction. So here we will pass len of the vocabulary size. Okay. Okay, it's issue. I will not try to solve it right now. So, okay, do you have questions? What is going on into decoder layer? I mean into decoder class, sorry. Okay, if not, we will move to sequence to sequence architecture, and so right now we integrate both classes. I mean, encoder and decoder, using teacher focus and during training to decide when to use the true target or the model's predictions. We can see it in the seq-to-seq class. You can see here that we pass encoder and decoder to our class, and also in this class we need just put all of elements together to create architecture that we need. So we can see here we have self-encoder, and we can find here we pass our sequences to encoder lower. Then we will have hidden and cell, and we pass to decoder lower our hidden cell inputs. And yeah, and in the end we can use our outputs. That was we passed our inputs to self decoder and get outputs hidden and cell as elements, and we can okay, we get it. So we can just return outputs when we will finish to process it. Here we have some constant values. It's input dimension. You can see that we pass length of our vocabulary, and you can see that output dimension would be length of our second vocabulary, like second tokenizer. And so, okay, we set all of the elements. Now we can depth to training loop. The training loop iterates over the batches, computes the loss, performs backpropagation, and updates the model weights using gradient descent. We can see it in our training training function. Okay, we see it on all of the classes. You know that we need pass train mode to the model, and we will have optimizer 0 grad in the beginning to set zeros to optimizer. Also, we will have process to pass all our sequences to model. We will have output, then we will measure how what's differences between our targets values and output of our models. We can okay, we can see our criteria of our loss function, that it is cross entropy loss. Usually we use cross entropy loss when we work with texts, because we work with frequencies. We have kind of classification task, but it's not binary classification. It's like multi-class classification, because we have a lot of tokens in the vocabulary, and we need to identify on each step which token signal with higher frequency. If it is the highest value, we said that okay, we need to use almost this token, and we can move to another step. After loss, we need to use backward function, and then we will compute loss item. In the beginning of the class, I explained splits to validation, test, and train. And I said that we will have graphics with our loss value. So we needed to set our graphics to observe the tension. And here we will have evaluation step to have check that we have good metrics in the training process, and we will pass validation that split of the dataset in this function. So do you remember what's the difference between training loop and evaluation step? You can compare this code in this cell and this one, and maybe you will identify some differences between this function and training loop. Okay, I will repeat that in the training loop, we loop over batches of data, perform forward path through the model to get predictions. We compute loss using cross entropy. We use backpropagation of the loss to update the model parameters. And also, one second, did you met this function earlier? I think no.
I don't remember this. Clip the gradient, I don't recognize it, and I really don't know what does it mean to clip the gradient.
Yeah, okay. We use gradient clipping, which prevents gradients from becoming too large, a common issue in training RNN's model. And to avoid it exploding, we use gradient clipping to exploding gradient problem. So when our gradients move to high values, we just cut it. It's a simple way to understand what is going on here. We don't allow our model to have too big gradients. We use okay, we use some maximum value to ensure that gradients in our model not lower than this threshold. Okay, so let's just let's see what's the difference between evaluation function and training. Can you name some differences? Maybe let's start with first two lines. Let's just like this. I think it would convenient for you to see differences. Okay, so we can see in the training mode that we have point train function for the model. And here we have eval mode of the model. Because, wrong? Okay. Because, so on the training, we need dropouts and batch norms. But on evaluation step, we don't need these components. So we need to identify that our model in the right mode. Also, we have this torsional grad to save memory and speed up computations. So we not allow our model to have gradients on the moment. We signal to our model that we will not have back propagation on this step. And this function will compute the loss on validation data to monitor our model's performance. Is it clear?
Well, yes.
Okay. Okay, let's just move on right now. So here, 1 second. We have I want to try training loop, sorry. Yeah, okay, so I find this. Okay, here we have training loop and we loop through several epochs training the model with the train function. We can see it here. We discussed what we have in that function and evaluating it with evaluate function. We save the model whenever it achieves a lower validation loss than before. You can see this component here, this statement. Do you understand why do we need to do like this? We discussed it earlier.
Yes.
Okay, can you explain? Let's refresh just knowledges because we discussed that we have training dataset split and we have validation and test. And can you answer on the question, why do we need safe checkpoint of our model on the lower validation loss value?
Well, we are interested in the point when we have to stop the training process.
Yeah, so I explained earlier that we have overfitting process and underfitting process, and I provide example of how can we monitor it with metrics, but we can monitor it with loss values too. But it would be a different if we had a situation with metrics that we need to identify whether our metric became lower, in what moment it became lower on the validation split, and we needed to ensure that we have a good metric and on training data set split and on validation too. When we measure our performance of our model on the loss value, we have opposite situation when we need to identify whether our loss value became not so not in a low point. So we need to identify when it moved to bigger value, and in this situation we will have signal that it's not okay for us. So I will provide you some visualization if it was not clear. When we use metrics or recognize, is it a good situation or no? We have this situation. Let's imagine that we have here training split and here validation. So we need our metrics be, let's imagine that it would be, I don't know, let's imagine just accuracy. We had on the first epoch 1, it would be, for example, I don't know, 0.2. On the epoch 2, we will have 0.4, and on third epoch we will have I know, let's imagine that it would be 0.7. But on validation split, we had this situation. We had we had on the first epoch, let's imagine that it was 0.1. On the second, it was, I know, let it be 0.42. But here we observe that we have 0.2 and it's lower than on training split. And this signal us that we need to stop here. But if we would have not metrics, we will measure it on loss value. It would be this situation. Let's imagine that loss was Okay, do you understand that loss corridor of each model is different, and I can explain you with loss of 2, for example. Maybe on the another model it would be I don't know, this high of our value, and on the third model normal loss would be in this breaks. Is it clear?
Yes, that's fine.
Okay, let's imagine that we have normal loss around 3 value, and it would be like this. We will have we'll have 4.5 on the first training epoch, that we observe that it get lower, and it would be 3.4, and on last epoch it would be for example 2.7. But on validation split, we see that it was, for example, I don't know, 4.9. Then it became lower, and it set it to 3.4, for example, and then it became higher. It became 3. No, okay. Let's imagine it became 4.2. In this situation, we need to stop on epoch 2 also, because our loss on validation split became it stopped falling, and it's not a good signal for us. So because of this, yeah, we need this statement that we check, we save checkpoint of lower validation loss. Okay, and also we have where is it? Yeah, we have PPL metric. It's function that helps convert loss values into perplexity. It's a common metric in natural language process, and it shows us is our model sure in its answers or no. We can explain it like this. You can see here that while our training process it's became lower, so it's a good situation for us when our perplexity became lower and lower. In this case, we can say that our model have knowledges that we need in our task, that it becomes more sure in its answers, and yeah, and I think that's it. Okay, so
Yes, wait a minute. So high perplexity is the high degree of insurance.
can you repeat, please?
High perplexity means that the model is quite sure, or
no, lower perplexity.
okay. And
okay, I mean here on first epoch it's
PPL is perplexity, is for perplexity.
yeah. yeah, I mean that on the first stage, it's not sure. On this stage, it's became more more quite sure in its answers, and here, for example, it's the best situation for us. It's not like this. We have lower, but you need to identify tendence. Okay, so here we will have, no, not here. Wait. Okay, I think we didn't discuss what is going on in this function, but it's quite important for us because we will have it lower. We will have it in okay. We will have it in the end of our notebook. Okay, so let's depth on. Here, here we have function that will translate sentences from German to English, and we can discuss what is going on. First, in first stage, we tokenize the input sentence. It's here. Then we process it through the encoder. We can see it here. Then we generates a translation word by word using decoder. We can see it here. You can see that we have for loop, like we start from the first time, and then we move to the last length. And it stops when the model predicts the end of sequence token or reach the maximum length. I mean, it was autoregression task, and we on the training process we made knowledges of our model to generate a token that would be on the further step, and I explained to you that on the further step, for example, we will have multi-class classification for all of our tokens. And for example, on the first stage, it's highest frequency to token I. And on the second, it's higher frequency of token love. And then we will have context I love, and it would be, for example, on third stage, it would be higher accuracy for cats, for example. And if our model think that we translated all of what we have in the sequences in the beginning as inputs, and it can predict further, but okay, it wants to stop on this moment, and in this case we will have the higher frequency of our end of sequence token. I mean, this is would be token with the highest frequency. And when we get end of sequence token, our model will stop prediction of previous token. Is it clear? And maybe we will not have, for example, we had a sequence of long sequence, and but maximum length we state to 5 words. In this case, it would stop on the 5th token. Do you have questions for this moment?
No, that's clear.
Okay. So yeah, good. And then we have get an example translation. Here we can just display example translations and demonstrate translation on sample sentences. We just you can see that we use previous function, and in the beginning we understand what we want to get as inputs of for function. Here we join our like different tokens on the whole sentence. Yeah, and get string type. Okay, and in the end of the notebook, we can demonstrate how does it works. But today we had issues in the code, maybe some issues with the environment. So you can see how it worked when we created this notebook. The first sentence input was on German, and we wanted to translate it into English. So it's our target predictions, and this what we get it with our trained checkpoint. So I think it's close to the target, but you know that we didn't have much, like a lot of time, and we didn't have state-of-the-art approaches right now. So it's okay that it's not you didn't get quality of text like in Google Translate translation. Yeah, so I think it's okay. And in the end, we just we can load our checkpoint, which we saved on the west stage, and we can evaluate, we can measure our metrics. We can see that we have here, I think, the lowest perplexity metric which we had, and it's kind of low value for the loss function. Okay, I think it was all material that we had. Today we learned about sequence-to-sequence models, how to implement them for machine translation. We built an encoder-decoder model with LSTMs, trained it on a German to English dataset, and generated translations. Okay, do you have questions about all the information that we have had? maybe some questions not about these materials. Okay, if not, I can stop sharing the screen. You will have a deadline in 3 days for the homework, for the first homework. After 4th of October, I will check all of the works which I get. And then you will, I will send you second homework. You will receive all the materials that you need for this work, and you will have 2 weeks for completion all of the stuff that you will have in the homework. And I think that's it. Yeah, also I will create branch in the GitHub repository of our year, because we will have around 5 new lessons. It would be 2 lessons for large language models, 2 lessons for advanced techniques of large language models. It would be a mixture of experts, PEFT method, merging of models, others, and I think the last seminar would be RAG, retrieval augmented generation. And one of the students asked me to provide one more lesson for it's okay, SSM models. It's kind of continue of RNN's model. If we will have time on this, I will do some extra lessons.
Okay, that's quite nice. Thank you.
Okay, so if you don't have questions, we can stop our lesson and go in for the rest.
Okay, just one moment. If you would manage to solve the trouble with this notebook, please don't forget to let us know, because I really want to make it work at main stage.
Yeah, of course, I will try. I think not tomorrow, but on Thursday, I promise that I will try to complete all of the issues that had.
Okay, thank you. And thank you for the lesson. Goodbye.
Okay, thank you so much for your attention. Have a good evening. Goodbye.
Bye.